I would like to thank the co-chairs, Representative Pignatelli and Senator Goby, for inviting us to do this. We really appreciate it. And I think I just saw that Senator Goby has joined the meeting. So Senator Goby, maybe at the end, I'd love to just invite you to make a couple quick comments if you'd like to. And also we've got some other TURI program staff who have called in. I believe that our co-director Joel Tickner is on the line, and Tiffany Skogstrom, who is the acting director of the Office of Technical Assistance, OTA, so they can also help to answer questions as we get to the end. Okay, so just very briefly to review, I think many of you already know this. We are part of the Massachusetts Toxic Use Reduction Act, or TURA. The goal of this law is to help Massachusetts businesses and communities to reduce their use of toxic chemicals while also promoting the competitive advantage of Massachusetts businesses. And the program is implemented by 3 entities working together: MassDEP, the Office of Technical Assistance, OTA, and the Toxic Use Reduction Institute, or TURI. And we'll say a little more about what we each do. Again, very briefly, the requirements of the TURI program are that businesses that use large amounts of toxic chemicals are required to report on their chemical use each year. They do what we call toxic use reduction planning every 2 years, and they pay an annual fee, and that supports the work of the program. And last slide before we get to our big topic, which is PFAS, is just to mention our decision-making structure under TURA. So we have 3 boards and committees that work to make decisions when, for example, we are adding a chemical to the Massachusetts list of toxic or hazardous substances, or making other policy decisions. We have a science advisory board, which makes scientific recommendations. We have an advisory committee that provides multi-stakeholder policy input. And finally, we have an administrative council, which is composed of agency heads or their representatives from multiple state agencies, and they take votes when we're doing something like adding a chemical to the TURA list, for example. Okay, so that was just like the 2-second overview. I think probably many of you already know that information, but for those of you who have questions, we can go back and do more details at the end. But now we're going to dive in and talk about PFAS chemicals. So what are PFAS? These are per and polyfluoroalkyl substances, which is really a mouthful. And I think many of you have probably heard of these chemicals. And so what we thought we would do is we just thought we would try to share a little more of the basics of what they are and what we've been doing as we conduct research on these chemicals. So PFAS, all these chemicals have a fluorinated carbon chain. That will mean something to some of you and probably won't mean anything to many of you, and that's fine. But if you look at this picture that I've got on this slide, you'll see there's a little jagged line of the letter C. So that stands for carbon, and so that's a chain of carbon atoms. And then you see lots of F's, and that's for fluorine. And so you'll see there are lots of bonds between carbons and fluorines. And that is the carbon-fluorine bond is a very strong chemical bond. And that's one of the key things to understand about these chemicals is that because they have this carbon-fluorine bond, they're very stable and persistent in the environment. They don't break down under normal environmental circumstances. Another thing to understand is that this is a large class of chemicals. The Organization for Economic Cooperation and Development, or OECD, has done a lot of work on them, and they have identified 4,700 PFAS chemicals. Depending how you count them, you could it could be a slightly different number, but basically there are thousands of these chemicals. Sometimes people get a little confused because of the nomenclature. So there's one chemical called PFAS, P-F-O-S, and that's actually the one that I showed in the picture here. And that is just one chemical, and that sounds similar to this other word, PFAS, but PFAS are this large category of thousands of chemicals, whereas PFAS is just one of them. So that sometimes comes up as an area of confusion. The PFAS are found in a wide variety of situations. They're used in manufacturing applications, in consumer products, and in firefighting foam, among other things. So you'll see from this picture, they can be used for water and stain-resistant coating on carpets or on furniture. They can be used in food packaging. They can even show up sometimes in cosmetics. And the firefighting foam is a particularly notable use because that's a use where it can get dispersed directly into the environment when it's being used. So I will now pass it along to Liz to continue from there.
Thanks, Rachel. So PFAS, as Rachel mentioned, they are highly persistent chemicals. They don't break down under normal environmental conditions, and they stay in our bodies for a long time as well, some for years. They're also very mobile. They contaminate groundwater in areas near where they're used, and are also found widely around the planet, including in the Arctic. Some PFAS bioaccumulate in animals and people, and some accumulate in plants, but because of their persistence, they all build up in the environment. So they're associated with a wide variety of health effects. We've listed a few of them here. For example, liver and thyroid effects are very common among this class. PFOA has been shown to affect your cholesterol level. So we have a lot more information on the details of the health effects if you are interested. I wanted to highlight the immunotoxicity. So studies have shown that higher levels in your blood reduce the effectiveness of vaccines. So this is a particular concern with the COVID-19 pandemic, where we're going to be relying on future vaccines to protect us. So we don't want chemicals in our bodies that are going to reduce the effectiveness of those vaccines. And as you'll see in the next slide, they have effects at very low concentrations. Next slide, Rachel. So what are our concerns in Massachusetts? This is a map from February showing drinking water contamination in Massachusetts. Mass DEP, the Department of Environmental Protection, is proposing a drinking water standard, a maximum contaminant level, or MCL, of 20 parts per trillion for a sum of 6 of the PFAS of highest concern. So 20 parts per trillion is a very small amount. They talk about a part per trillion as being a drop of water in an Olympic-sized swimming pool. And that low MCL is because there's strong evidence that these chemicals have effects on people and other biota at very low doses. So in February, they did monitoring of public water systems, and they found 20 systems in 13 different areas that had wells that exceeded that level of 20 parts per trillion. So those communities either already have or are now taking action by installing expensive treatment systems, maybe by blending water sources, like mixing more than one well together, or shutting off wells. Some of that contamination is due to industrial sources, but the majority of the contamination that we have found thus far is from the aqueous film-forming foam, as Rachel mentioned, the firefighting foam, or AFFF, at military bases and at firefighting training sites. And I'm not sure where all of you, what your districts are that you represent, but you may have some of these in your district. So currently Mass DEP also has a large sampling program underway, a new sampling program of both public and private water supplies. So we'll be watching for that data when it gets collected and then analyzed. So this protection of public health and looking at our drinking water right now is very important. But every day we also add to this burden. Next slide. So how do we turn off the tap, so to speak? How do we stop more of the chemicals from getting into our environment to the point where we then have to clean those up as well? So we want to make sure that we can achieve our public health goals and reduce the environmental burden, not by just always trying to clean up what's already been put in the environment, but by trying to prevent it. So we need to do the same thing that we ask companies to do in the TURI program when they're using toxic substances. They need to look closely at the use and say, is it necessary? Can we make good dental floss without PFAS? I think we can. Are there ways to use less or avoid emitting it to the environment where it will never go away? Are there safer alternatives for critical uses, like that firefighting foam, which is a critical use? Let's find safer alternatives. So the TURI program helps companies and communities by providing resources and technical assistance and doing research on safer alternatives. And all of this is to try to move companies and our communities towards safer and effective solutions. We also build awareness, and this is a really important thing for PFAS. So as businesses might in the future have to measure and report what they use and release, that information helps them to improve and to focus their own efforts on trying to reduce their use. And in the case of PFAS, it helps them figure out where they're actually being used, because it's not often obvious on the products or the lubricants or whatever materials they're buying that they have chemicals that will end up contaminating the environment at some future point in time. So, and it also, of course, helps the public with that information. Next slide. Next slide. Thank you. So the TURI Science Advisory Board, which Rachel mentioned as part of our decision-making process, they've taken several years to do a detailed hazard review of a subset of those PFAS. So we're going to insert an additional short chemistry lesson to the one that Rachel started here to help you understand some of the information that we're sharing, but also what you may be seeing at other places. So the basic structure of PFAS contaminants that you're hearing about is this carbon chain she mentioned with the fluorines, and we sometimes refer to that as the tail. And that might be a short one or a long one, or it might have oxygen stuck in the middle of it, but that tail is a defining feature of these PFAS. And the other end, or the head end, may have an acid group or any other chemical structure on that end. So that fluorinated tail is great at repelling oil and water, which gives PFAS one of its most unique characteristics. The PFOA that's shown here, which is what's called a C8 chemical, is also a legacy PFAS. And that means that it's one that is no longer being intentionally used by the larger companies in the United States and in most of the developed world. That's not true for many parts of Asia and other parts of the world. But it's one of the most toxic and most pervasive. Manufacturers have used it for years. And then when problems surfaced, they responded by agreeing to phase it out. And then they modified it slightly by making the tail less long, by making the tail shorter with fewer carbons, and then inserting that oxygen we mentioned into that carbon chain. So they've done some tweaking of the chemistry in an effort to make it less toxic and not quite as bioaccumulative. But nevertheless, these thousands of chemicals that you can make by adding all sorts of different kinds of functional groups onto the head of this chemical, they're still going to break down into something that remains in our environment for a long time. So this is how they manage to make thousands of possible chemicals, even though you may only be hearing about a small subset of those. Next slide. So here's another example that, again, we mentioned the firefighting foams. So they've been used to fight Class B or fuel fires for a long time. They're very effective. They work really well. And they have traditionally been made with the longer chain legacy PFAS. DEP now has a take-back program to get those substances out of fire departments. And manufacturers are now making these, this AFFF with shorter carbon chain chemicals. So while this is a small improvement, we're still going to be loading the environment with PFAS every time that foam is used. There are now fluorine-free foams on the market, and this is an opportunity to use a process we call alternatives assessment to make sure that we're making good decisions and adopting alternatives. So how do the substitutes compare for performance? Does it still do a good job of putting out the fire? For environmental health and safety, is it really safer? And for cost, can we afford it? So preliminary work's already being done and a lot more is underway. For example, TURI is going to be working with the Lowell Center for Sustainable Production at UMass Lowell on an alternatives assessment project for Department of Defense this next year. Mass DEP and OTA are involved in an interstate collaboration with Connecticut testing performance on some fluorine-free foams, and also trying to do an analysis to see what is actually in those, because we want to avoid regrettable substitutes. We don't want to substitute another chemical that, even if it's fluorine-free, has other substances of concern. Next slide. So here's a little bit more background. So the substances that you hear about, like those showing up as contaminants in drinking water. Now, how do they fit into this large class of thousands of chemicals that Rachel referred to? So many of those thousands of chemicals are complex chemicals, and they're used as raw materials or in manufacturing, or they're chemicals in commercial products like stain-resistant coatings or food packaging or those other uses that she showed you. But when they get into the environment, or when we use them, when they get into biota, like humans, they gradually break down into those terminal degradation products that are very persistent and then never break down. Next slide. So those terminal degradation products are the substances that we're measuring now in drinking water, in groundwater, and in our bodies. And so you see the acronyms of the ones that the SAB looked at the bottom there. They're the basic types of head-tail chemical that we showed you earlier, and they're the ones that our Science Advisory Board did a really detailed evaluation of. Now, above that, we're refer to the rest of those as precursors. So that means they are precursor chemicals to those terminal degradation products. So those are the more complex chemicals that will break down into what you may have heard referred to as forever chemicals, and they form, those complex chemicals form the rest of that class of PFAS. So our Science Advisory Board also looked at the evidence of those degradation pathways. How is it that those more complex chemicals then break down into these terminal degradation products that just never go away? So with that, I'm going to turn it back to you, Rachel.
Whoops, okay, am I unmuted?
Yes.
Okay, thank you. Great, so, okay, so as we've seen, there's a situation where we've got this large number of chemicals. There are similar health effects across this whole class of chemicals, and there's the potential for an almost infinite number of possibly similar chemicals where you can just tweak the chemistry a little bit and get something that's different but still a PFAS chemical. So all of these are reasons to look at PFAS as a category. Now, so we talked earlier about our Science Advisory Board, and they have actually spent the past 3.5 years studying in depth the PFAS, this set of PFAS chemicals, and that work culminated in the past couple of weeks with a recommendation. So they voted to recommend listing PFAS as a category under TURI. And in doing that, they drew on work that had been done by the OECD and other authoritative bodies. And they took account of the structural similarity, evidence of similar health effects, and these other factors. The next steps, now that the Science Advisory Board has made this recommendation, is that TURI will put this together with other policy information that we have, and we'll bring it to our TURI Advisory Committee and then to the Administrative Council for a decision about listing PFAS under TURI. And so the implications of the listing would be that we would be providing this information to Massachusetts businesses, and they would be required to do reporting and planning. And so the kind of the meaning of doing this as a category, or the implication over time, is that they would then be asking their suppliers to let them know if there are any PFAS chemicals in the chemicals that in the, the products that they're sending them, and they would be looking for safer alternatives and looking at ways to prevent all of these chemicals from ever entering the environment. So again, just sort of trying to address the issue up front rather than later once it's a contaminant in our environment. Shifting gears a little bit, another thing that we've been doing just for background is we've been looking at what the policy approaches are in other states, and there are a lot of creative approaches that are being taken, around the country. So these include environmental monitoring. California is doing biomonitoring, so actually looking to see what is in human bodies. A number of states are working on drinking water standards, groundwater cleanup standards. Some are focusing on labeling and disclosure. For example, the state of Washington is requiring reporting of certain PFAS if they're present in children's products. There are product-specific regulations in some cases. Again, to take an example from Washington, they have adopted a law that will prohibit PFAS in paper food packaging. Some are taking the approach of environmentally preferable purchasing programs. So, for example, in Minnesota, they've adopted specifications within their EPP program requiring that compostable foodware should not contain PFAS. And finally, a number of states are adopting statewide chemical action plans. So Washington, Maine, Michigan, Connecticut, and there are probably others are doing these statewide plans. Okay, so since we're keeping this quick, I'm going to stop there on PFAS and just give you quick other information about the TURI program, and then we'll move on to questions. So as many of you may already know, TURI has a number of activities and work areas. We do education and training. One of the things that we've been getting a lot of questions about recently is safer cleaning and disinfection. So we have a bunch of information now on our website about that. We give small grants to businesses, municipalities, and others to help them do toxic use reduction projects. We do demonstration events at businesses that have found creative ways to reduce their use of toxic chemicals, and we actually have one coming up, River Street Metal Finishing, on July 23rd. So this is going to be a virtual demonstration. We did our first virtual demonstration recently, earlier this month, and it actually was a big success. It was a really good event, and we've got the recording of it on our website, and this should be really fun as well. So it's a chance for you to kind of get to see the inside of a facility and what they're doing. And we have a cleaning laboratory. We do work groups where we bring people together from different parts of an industry sector to solve problems together. And we do policy analysis work. So please feel free to reach out to us for any questions you have about chemicals at any time. And then our partner agency, the Office of Technical Assistance and Technology, or OTA, provides free and confidential technical assistance to Massachusetts businesses. And so please refer your constituents to OTA. They provide really wonderful services. They can help people with compliance, help them avoid accidents and spills, help them find ways to reduce their costs, and all of this in the process, they're helping them to find ways to reduce their use of toxic chemicals. They also have a really great program on chemical safety and climate change preparedness, where they've looked at the vulnerabilities of communities that could be exposed to the effects of extreme weather events associated with climate change, and then looking at chemical risks in those areas and ways that we can reduce those chemical hazards. Last thing is I want to ask you a quick favor while we're on, and that is that we'd love to have you just put some quick comments into the chat, and we won't try to read them all right now, but we'll save them for afterwards. And we'd like to know from you whether you would like to hear future mini briefings, and we'd also like to know if this format worked for you. Was it too short? Was it interesting? Would you like us to do anything different? And we were thinking about topics that we could cover in other briefings. So a few that occurred to us were we could do something on safer cleaning and disinfection, which again, people are thinking about a lot in the COVID context. We could talk about our research on safer athletic fields. We've done a bunch of research on artificial turf and safer alternatives. And we could also do a mini briefing on what we can learn from the TURI data. So as I mentioned, we get data every year from Massachusetts businesses, and we analyze the data, so we could share what we've learned from that. So again, if you don't mind, just whatever quick thoughts you have, put them into the chat and let us know, what you'd like us to do in the future if this sort of thing would be of interest to you. And finally, please reach out and contact us at any time. Just to keep it simple, we put 2 email addresses here. So if you have questions for TURI, please contact Liz Harriman. And if you have questions for OTA, please contact Tiffany Skogstrom. And so now, Senator Goby, can I ask you, would you like to just say a couple words before we open it up for questions?
Sure, I'll be happy to. And a little bit groggy. The Senate we were in till about 4:15 this morning, so I'm not running on all cylinders right now. But I appreciate you doing this. And actually, I like this kind of quick hit. I thought it was very beneficial. And thank you for the work that you do. I know it's always kind of a nice event that we have at the State House when we're able to recognize the businesses and the work that you do. So hopefully we'll get an opportunity to do that. I do have a couple quick questions. Is that okay? Okay.
Great, yeah.
Just, I saw that Rep. Nod had asked about sharing the deck, and I saw that you put that. The other thing I was going to ask, because yeah, I didn't do too well in chemistry when I was in high school and college. So do you also have like a little, maybe a white paper to kind of explain in sort of layman's terms some of the chemistry that you talked about in this? I don't know if that's possible. So that's one request. The other I was just going to ask too, when you mentioned about the working with Department of Defense and that you're going to come out with some sort of study, do you know, will those results of that study be publicly made, or is that just for DOD to come take a look at?
I believe that will be public. Joel, are you still on?
Yes, it will be public. And what we're going to be mainly looking at is, you know, what's out there. How does DOD define adequate performance, and what is adequate performance, and then looking at the range of alternatives that are available, and if they do meet those performance guidelines, and what do we mean by safer. So, but those would be public. DOD is doing quite a lot with the work under this program called CERTIP to make the results widely available, because DOD doesn't want to have to clean up messes anymore.
Right.
So they want the better alternatives.
Okay, thank you. And then just, and I don't know if this is something you can answer or not. Obviously, when everything came out with PFAS, it kind of took a lot of us by surprise, and obviously the municipalities by surprise, and the extra cost. And you've seen what we've had to do budget-wise. Is there, should we be prepared for something else kind of coming down the pike, some other chemical thing that we should know about that you already know about that hasn't kind of hit? Is there something else that we should be preparing for? Thank you.
That's a hard question. Maybe we could just say that one of the things that our Science Advisory Board is going to be taking up in the next year is to evaluate some nanomaterials. That was a petition submitted by some advocates of environmental and labor advocates to say, you know, what do we know about these substances, and should there be, you know, should they be part of the TURI program so that companies are more aware of, you know, that they're using them and that they have health and environmental effects. I guess they're one of the classes of substances that are largely unregulated now. Rachel, other thoughts?
Yeah, no, I think that's probably the only answer that I would have given also, and it was a very good question. Just on the question about some kind of little kind of chemistry primer, we can send some fact sheets that were created by ITRC, the Interstate Technology Research Council, which I think might be the best resource on that. Although, Liz, I don't know if there are other kind of primer resources that I might not be thinking of.
So that's probably the best chemistry primer, but it's not necessarily made for a lay audience, I think, as much as a you know, Department of Environmental Protection kind of audience. But we can send you, there are some other, particularly fact sheets about health effects of the substances. So yeah, I think both some of the more simple health effects fact sheets as well as that, the ITRC would be good.
So thank you, everybody. It's 1 minute after 1:30, and I wanted to really respect everyone's time. We will be happy to stay on and answer more questions if you have them, but I didn't want anybody to feel like they had to stay on if they had other things scheduled. So I want to thank you all for joining us, and if you do have additional questions, please feel free to stay on and ask Liz and Rachel.
And again, thanks to all of you for joining us for this, and thanks for all the hard work that we know that you're all doing.
Yes, absolutely. Were there any other questions, Pam, in the chat? I wasn't watching it.
There was definitely some reaction to Rachel's question about what other topics would be of interest. Laura Spark also shared some information about some legislation that's been proposed on PFAS, and so that was very helpful. One person asked for the link to the information on drinking water, which I was able to share, but no other specific questions. So, and I don't hear anybody piping up on that.
No. Are any of you that are still on the phone, are you in districts where they are having contamination concerns in the public water supply or other places?
Hi, this is Drew. We're not, I don't think we have any contamination concerns according to that map, but I did have a question that just popped in my head. Is there a method for extracting these chemicals out of these public water supplies, and how difficult and what's the cost of that? And then if it's possible to extract them or break them down, do they get broken? Can they get broken down and put somewhere else, or are they sort of just a nuclear waste? We put it in a bin and have to never touch it again.
Yeah. Have you read The Cat in the Hat Comes Back, Drew?
No, I haven't.
You should read that one. It's about some pink stuff that just keeps getting moved around and seems to expand rather than getting cleaned up. It's a Dr. Seuss book. Anyway, you're absolutely correct. We can take it out of drinking water. One of the complications is that those longer chain legacy chemicals are readily removed by something like activated carbon, but it doesn't remove the shorter chain chemicals. So if we're going to remove all the contaminants that might be in a particular water supply, then we may need multiple treatment technologies. And activated carbon is not cheap. I believe that the Cape has spent somewhere around $1 million on their units. And of course, activated carbon needs to be, rejuvenated fairly frequently, depending on how quickly it fills up. And once you take the substances back out, they are not being destroyed. You're absolutely right. They're being gathered in the activated carbon, and then you still need to do something with them. You need to put them in a secure landfill or send them to an incinerator. And we're still not exactly sure how great a job the incinerators are doing at full destruction either. We know that some of them are not doing a very good job at that.
Great, thank you. And are sort of the activated carbon and methods, are there any methods that require, aside from sort of the carbon or whatever chemical that you need to clean it, more dedicated machinery, essentially, in a water treatment plant?
Yeah, I think the only ones that have been installed in Massachusetts or in New England at this point are probably what they call GAC or GAC, the granulated activated carbon. But I believe that there are some ion exchange systems that they're trying to use for the shorter chain. But it's sort of the same idea where you're actually just pulling the chemicals out and then you use onto a different media. Did I get your question?
Yeah, I think so. It was sort of aimed at, like, if a water system is contaminated, is it the cost of, are there basically a whole new set of treatment machines like you would upgrade a water treatment plant? Do you have that, and sort of that's with you now, or can you sort of just bring the chemicals in and out? I'm not a water expert, obviously, or how these things happen, but is it going to be a large infrastructure cost when these are happening, or is it just sort of the cost of, is it a mobile thing? I don't know.
Yeah, there will be an equipment, definitely a capital equipment cost to put units like that in place. And then there will be also the recurring cost of new media like carbon.
All right, great.
So
Thank
there
you
will
so
be
much.
both.
So we have a couple other questions that were posted on the chat. Paige Fisher has asked if this topic of PFAS chemicals has any correlation to environmental justice, and if there are any communities specifically affected by the contamination more than others.
I'm not sure if anyone else has another answer to that. I know that in some parts of the country, that is absolutely the case. There's an area near Decatur, Alabama, that has very serious environmental justice concerns on the river there, and many fluorinated chemical plants as well as other chemical plants upstream of communities that have not been well served. I don't know in Massachusetts whether there are EJ concerns. I think at this point, most of the heavily contaminated areas have tended to be around the military bases and some industrial facilities. But in Massachusetts, I think it's certainly overwhelming the military bases. So I don't know if that ends up as an EJ concern. Maybe others have thoughts.
Yeah, I think that's a great answer, Liz, and I don't think I have anything to add.
Okay, let me just pose the next question, which is, where can we get information about firefighting training at airports? And if there is ground soil testing, not groundwater testing?
So just one quick piece on that is that it's much easier to test water for these chemicals than it is soil. Once you get a soil matrix, as they call it, it gets much harder to detect the substances. And I don't know if they have done soil testing. As we mentioned, these substances in general are very mobile. So once they hit the ground, and you know, it rains or anything, they will tend to percolate down into the groundwater. So I'm not sure if the soil is as much of an issue. And airports are, in fact, a source. They don't do as much training as some of the firefighting training facilities, but I would say the answer is yes. We have not seen, I believe they did testing at Logan, and I don't know that they found contamination, but I could be wrong. I don't really know the answer to that. We can find out.
Great, thanks. Are there any other questions that people would like to pose? Either you can unmute yourselves or you can type it into the chat.
Just one more thing to add about the airports is that I know Logan Airport has been researching ways to either use less of the AFFF or implement the fluorine-free alternatives. They are one of the airports that's trying to be a little bit in front of the game. So I'm pretty sure they're active. I haven't talked to them, but our colleagues on the West Coast who are working very diligently on this, their airport folks have talked to the folks at Logan. So